G'day guys, Alan here. Welcome back to my workshop. Sitting here today beside the Victoria mill. Want to explore a problem I've got with a noise in the drive to this shaft. This is the shaft that powers the feed gearbox and raises and lowers the knee, moves the table around. But there's a chain in here which we'll look at a bit more closely, and I'd like to explore why that chain's so noisy. So we'll move around the other side and check it out. Okay, I've had this apart already, so I know how to explain what's going on. But anyway, starting here, as I mentioned, there's a chain that runs around in here, and there's a sprocket, of course, in here. And what I wanted to do was pull this plate out, pull it all apart, and have a proper look at what's going on. Now, these two bolts here, I confess, are a mystery to me. We can see that this is countersunk for some reason, the other one's the same. So clearly these aren't the original bolts. But attempts to, and we can also see, well, you take my word for it, there's a grub screw in here which engages in a divot in the side of this thing. There's also a grub screw over here which is put in on the boundary between this this round piece must be some sort of a bearing support for the shaft that's got the sprocket on it, and this grub screw here is on the boundary between, I'll call it a bearing support, and the back of the column, and it's just there's a drilled hole and it's tapped into it, and its purpose is simply to, I'm sure, to stop this from moving in or out or from rotating. Now, I don't like these things because if you do take them out and then do manage to get this piece out, your chances of getting it back so that thing lines up exactly aren't very good. Anyway, so far this thing has defeated all of my attempts to dismantle it. So what I tried was putting screws into here and having a bridge across and using a puller to try and pull this thing out. Oh, train siren there, let me say that again. What I've tried so far is to put two screws in these holes and use a bridging bar across and try and pull it out. Didn't work. I tried putting a screw in and pushing against the bottom of the hole in case they're meant to be jacking screws, although if that was the case I've got no idea why they would have countersunk them, but in any case that didn't work either. I've tried putting with the two screws in there a bar between them to try and get some leverage this way, and that didn't work either. So basically I have to admit defeat on dismantling that. I don't know how to do it. So let's pull this off and have a look in there. I'll try not to get in the way. Try not to get in the way of the camera too much while I do it. Oh, so sorry. So what is this piece? I don't think it's original to the machine. That's the first point, but we'll come back to that. And I worked out that it's actually a chain tensioner, and this piece here is an eccentric pivot. Well, that'll become a bit clearer when we get it out. And I found the easiest way to get it out is actually to oh, come on, is actually to take the plate off and then come back for the tensioner. So we'll do that. Come on, I'm trying not to get my in the way of the camera. There we go. We'll have a closer look at that plate. Have a closer look at that plate in a minute. So that's an idler, and I think you'll be able to see the eccentric I was talking about now. So when this is mounted in that plate, as you rotate it, it moves the centre point of that pivot. Anyway, we might have a closer look at that later. So hopefully what you can see now is the chain is incredibly slack, and now I understand how that chain tensioner works. Even when it's set for full deflection this way, the chain's still too loose. So it would be nice if I could pull it all apart, but as I say, it's defeated me so far. What's also curious, if we rotate this round a bit, we can see there are actually two joining links in the chain, and I'd be pretty sure it didn't leave the factory like that. So my assumption there is that somebody decided that there's so much slack in the chain they'd try and take an extra link out, and when they did that, it didn't reach. I don't know whether that's right or not, but anyway, it's the only reason I can think of why there might be two joining links there. Other point to make is this sight glass thing here was in pretty poor shape, so I took it out and completely refreshed it, so we'll see a bit more of that later on. But that tensioner does hold the chain right over here, and now I understand how the thing works. If I set it up with the maximum thing, it takes most of the slack out of the chain. So, and obviously I need to clean this face up, get rid of this old gasket material. So I'll keep going with that and bring you back when I've finished. Okay, so that's got the face scraped off there. So now I'll run a tap through there to clean the crud out of the threads. So I won't bore you with all of that, but I'm going to do all 4 holes. So as I said, I don't know whether the chain tensioner was original to the machine or something that somebody made later, but looks like this hole was original to the machine, because that looks like, you know, just roughly where the casting ended. It's never been machined around in there, and I can't imagine if somebody put this hole in after the fact that they would have left it looking like that. So maybe originally there was just a cover plate on here. But if I look down inside the hole towards this piece here, I can see the sprocket that's on the end of that chain, and I can see that there's a grub screw in the hub of it. But getting an Allen key on it down in there would be a bugger, and then who knows what would happen if I tried to actually take it out. But without being able to pull this out, there's no point anyway. Well, plus the other thing is that if I did actually manage to get it out and had to put it back, if I didn't get it back in exactly the same place, which would be nearly impossible, then I wouldn't be able to get that screw back. That's why I hate these things. Anyway, we press on. Okay, so now I've got to put the 4-hole pattern into the 2 thickness of gasket material that I've made. So I've clamped them underneath the sight glass ring and run a 1/8 drill all the way through into the block of wood. So that should have given me 2 sets of 4 clean holes. So we'll have a look at that. And I've marked what will be the top of the thing, so I hopefully can preserve the alignment of all the bits, because I've learnt from previous experience with this machine that not all the hole patterns have been done with a DRO or something equivalent, and so things don't necessarily work if they're rotated. So anyway, we'll pick this up. Preserving that alignment. Okay, so I've got my gaskets. I've got my gasket goo. Now this is some sort of perspex or something in there, and originally it has a piece of cork on this side, and originally had a piece of cork on the other side as well. And I've made this ring out of a piece of very thick gasket paper to sit in there, and its purpose will be to make sure that nothing tapping this from the back can push the glass in. And I've made a couple of holes or what do you call them, insets or something, so that when all these gaskets go on, but particularly this one, these two holes here to allow oil to come in from the top and drain out from the bottom and show the oil level against the that line. So it's important to have clearance for that. Alright, well I think I'm ready to start again, but I'm not planning on putting any goo around this. I don't think it needs it. Now there's a mad trade in the background doing something with a circular saw. I'm sorry about that. I've apologised before. So anyway, let's start getting some of this. This is a non-hardening goop, and I want to be a little bit sparing with it. This gives you plenty of time to work with this stuff. So it suggests that you give it a few minutes after you put it on to allow it to go tacky. So that's that bit. So I'll put one of these gaskets over. Don't try and turn around on me. So I've marked your top anyway. So we'll put you on there. And another layer of goop on that. Alright. And now we can put this on. Another layer of goop. Managed to flick stuff all over the place. And that. Reorient myself so I don't lose sight of where the top is. And we'll put this one on there. Alright, see if we can get this some screws into this thing from the correct side. Well, that's one, that's something. Well, it's got the screws in, so let's see if we can install it without getting into too much of a mess. Alright, so I've got all the screws mounted. And hopefully I haven't blocked that drain hole at the bottom. Just have a wipe around. Any excess that's come out. Okay, hopefully that'll get the job done without leaking. Okay, so let's have a bit of a closer look at this fella. I think you can see there are tool marks here from the milling machine, a bit of hand finishing marks, so clearly this wasn't a mass produced item made by some talented tool maker at some point in the past. So I've put a mark here which you might be able to see, a little pink dot, which I'll line up with the pink mark here on this idler pulley assembly, and you can possibly see how this eccentric works a bit better now. With that not able to move, rotating about this forces this piece, well, you probably get the picture, it moves the centre of this. Okay, so oh, and just as a curiosity, I've fished these pieces out at the bottom of the sump for that area, so clearly there was some sort of a drama with the chain at some point in the past. Right, so also I've made a paper gasket for this thing. It didn't have a gasket, it just had some sort of goo there, but I'm old school. I quite like the idea of paper gasket with non-setting goop each side. I'm no fan of silicone sealer. It has its place for sure, but for gaskets and things I prefer using this because you can always take the joint apart if you have to without getting yourself in a mess. Alright, so let's get ready to goop this up, and might give myself a couple of reference marks to see where to put the goop to. Because I've got it in mind to put the goop on this piece and the goop on the back face of this piece, so yes, this face. So when I've got this done I can just turn this over onto it and I won't have to try and hold it while I'm bound to get goop all over my fingers anyway. It's just the way these things go. But let's get started. So I'll bring you back when I made a bit more progress with this. You don't need to watch me doing painting. I'm watching paint dry, but one of the beauties of using this stuff is that you get plenty of time to work with it. It's that piece. You get some on the gasket. Yeah, and that's got it gooped up. Got a rag to hand. Alright, well, not too much on myself yet, but that's probably about to change. Right, so we'll put this guy in first. Hook this chain back out the way. You can just sit there and wait for the other piece to come along. There's my other pink mark. Okay, let's see how much of a mess we can get into now. So that's got to go on there. And we'll start with the bolt in the centre at the top. Not the correct bolt, but it'll do for getting a beachhead with the bolt pattern. Right, it's started. Come on. That's good. Started him. Right, you started. Looks like you've started. Get the right screw in there. I suppose they need to be terribly tight really. And I need a bigger spanner for this. We'll set this up so this is pointing in the right direction. Up there. Get the maximum tightness on the chain. Before we get really tight with that, so we'll have a look through the chain hole. Pretty sure that's the position where there's minimum slack. Right, so I've got a wipe round and a clean up, and I'll see if we can get it positioned so we can see that chain through the hole. Okay, I know that you won't be able to see this very well, but if you're looking through the hole there, you can probably see the chain just moving a little bit. So most of the slack is out. There's still a little bit there, but we'll fire it up in a bit, and hopefully with that small amount of slack we'll still be able to operate the machine without any problems. Okay, so let's put the oil back in the sump and put the plug in. I've given up worrying about exactly which oil goes in the machine. The books, or the reference material I have for it, quotes oil which Noah used when he was building the Ark, and you can't buy them anymore. And I come to the conclusion it doesn't matter that much as long as what you're doing is an appropriate sort of oil. So what I'm putting in here is hydraulic oil with a 46 weight. I'm not exactly sure what the 46 means. It's some sort of a descriptor of its viscosity, but I've used it in the other sumps on this machine and everything seems fine. So let's pump some of this in, and hopefully we'll see the level come up in the I did also put this plug back with some sealant too. Oh yeah, you just see the oil starting to come up now. Perhaps you can see that. Well, that's a good sign. This drum's getting pretty low too. To switch over to a new drum soon, I guess. Let's tip it over at an angle. See if we can encourage it to come up with a little bit more. Oh, yeah. We don't need much more now anyway. Perhaps if we wait a bit, I think we might call that done. Interesting. When I put the thing back, it's gone back with the red line, not quite level. It doesn't matter. We can see what we're supposed to be doing. Okay, so time to put the filler plug back in. I think that's a 1/2 inch BSP, but be that as it may, we'll encourage it to do the right thing with a bit of this sealant. This is actually a taper plug, so the sealant's probably not needed, but why give Murphy a chance is my attitude. And I think Murphy might be an English and Australian thing. Maybe Murphy isn't so well known in the US and elsewhere, but basically is the patron saint of everything that can possibly go wrong when it's most inconvenient. Shouldn't that be tight enough? And we'll just wipe off the excess. Anything on the outside, it's not going to do me any good at all. Okay, so now I've just got to put this last bolt back. I don't even know whether it needs sealant, because I don't know actually what they're doing. They did have some sealant on them, but I'm going to put them back dry, and if they leak, well, I'll worry about putting some sealant on them then. Click. Right, call that job done. We can see our oil's at a good level. I think it's time to do a test. Oh, that sounds alright. Let's give it a... So it certainly sounded fine on the slow speed. Let's get a little bit faster. And give it a serious test and see what we've got. Well, that's pretty good. That's about as fast as I'd ever run this shaft. Now, it could be noisier when it's under load, but I'm happy with that. You might have noticed, by the way, that when I turn the power off, this lot stops straight away. It's because there's a clutch in here, and when you put the power on, it releases, it's a brake, sorry. When you put the power on, it releases the brake, and as soon as you take the power off, the brake comes back on. That's why it stops so quickly. It's a pretty good feature. Wish my lathe had that. Right, clean up time. Okay, well, that's got that all wrapped up. I wasn't able to dismantle the chain drive and do what I wanted to do, because probably the sprockets are badly worn. But at least I was able to properly understand the chain tensioning mechanism and adjust that for maximum effect. And of course I also managed to do an oil change on that sump, which probably hasn't happened since who knows how long. Unfortunately the white plastic thing with the red line on it obviously has an asymmetric bolt pattern or hole pattern in it, and I didn't notice that before I did the reassembly, so it's gone back slightly off horizontal. Doesn't matter, it still gets the job done, of course. But anyway, so that's that. Hope you enjoyed that. Maybe if you have one of these machines, learnt something a little bit about how they how the feed mechanism works. But in any case, thanks for watching. I look forward to seeing you on the next one.